Hey all, and we're going to continue in chapter 3. So let's get our materials out for notes and we're going to get started. So today we're going to be talking about what's called inclusion and exclusion. And we touched on this a little bit in our last lesson, which is why you see number 1 is identical to our last lesson. So in number 1, which we saw earlier, you deal 5 cards from a standard 52 card deck. How many lineups are there that consist of all red or all face? And if you remember from that lesson, the issue is that the center part is counted twice. And so we had to calculate that by saying we're going to take all the red cards, and then how many lineups are there where it's just all the red cards, which was 26 permute 5, arrange 5, and all the face cards, there's only 12 face cards, picking 5, and then since the center was counted twice, we had to take away where the 6 overlapping that are red and face cards, and take that away, and we ended up with 7,987,920. And this is the idea of inclusion and exclusion, and this is always going to be true. If you're trying to find the cardinality of an overlapping set, like what we see up here, it's always going to be the cardinality of this first one. So if we take this left side as A, it's the cardinality of A plus the cardinality of B minus their overlap because you've counted them twice. We can use this for solving a lot of similar problems, and it doesn't have to be permutations, it can be any form of cardinality as well. So if I'm looking at a second example, a senior class has 27 AP Physics or CIS students in AP Physics or CIS Calculus. There are 12 students in both and 20 in AP Physics. How many are there in CIS Calculus? Well, I'm just going to start by saying, well, let's just call the set A as students in physics, and we'll call set B these are the students in calculus. And we're going to use this same formula here because we are asking for students who are in both A or B, which is given to us as 27, is equal to the number of students in physics, which we are given as 20, plus the number of students in calc, this is our unknown. This is what we want to solve for. And then, of course, minus the students who are in physics and calculus, which is given to us as 12. And so from here, it's just a very straightforward algebra problem. We end up with 27 is equal to 8 plus the number of students in calc. So the number of students in calculus is 15 seniors. So you can solve it where you're looking for the final number here, like we saw in number 1. You can also use it to determine one of the other cardinalities. Now, of course, if this works for 2 sets, it can also work for 3, though the formula is much more complicated. And we're going to derive it the same way. So if we look here in this set, we have A, B, and C. Now, these intersections here are being added twice. So we want to subtract those away. So we'll minus the intersection of B and C, minus the intersection of A and B, and minus the intersection of A and C. But now I want us to think about this centerpiece here. If you notice here, it's being crossed by the lines in A in A here, C, and B. So it's counted 3 times. However, it was also subtracted 3 times because it's in all of these 3 intersections. So subtracted once, twice, 3 times. So since we now are missing this section in our formula, so we have to add that back in. So our final formula for this, the cardinality of A union B union C, is A, B, and C, just like we started. We subtract away all of the intersections. So A intersect B minus A intersect C minus B intersect C. And then we have to add in that last intersection of all of them, A intersect B intersect C. So that's the formula if you've got 3 things like we see here. How many 3-element subsets of the digits 0 to 9 are there where they are all even numbers? So that's going to be our A. This is all even. B is all numbers that are greater than 5. And C is all prime. Now, sometimes it's helpful to actually write out these sets. Hopefully even you don't need written out, but it's helpful since we're going to do it for the rest. All greater than 5 would be 6, 7, 8, 9, just up to 9. And prime would be 2, 3, 5, and 7. Remember, 1 and 0 are not prime. So when we go through this, we can use our formula to say the cardinality of A would be, since it's a 3-element subset, we're going to use combinations. So there's 5, and we're choosing 3, plus cardinality of B would be 4, choose 3, plus cardinality of C, which is, again, 4, choose 3. Now we want to minus the cardinalities of their intersections. And here's where we come across a nice thing with combinations that we haven't reviewed in a little bit, is that if it's A and B, so it's all even and greater than 5, that's only 6 and 8. That's the intersection here. And you can absolutely write out, well, there's 2 and we're choosing 3. But remember, whenever n is less than k, that means that this is equal to 0. It is absolutely has a value, but it's 0. And so you're going to end up with this in a lot of these cases as you get into smaller and smaller intersections. So be wary of that. The next intersection would be all even and all prime. Well, that's just 1, choose 3, so another 0, minus all over 5 and all prime, which is, again, 1, choose 3, this is 7. And when we add in the intersection of all of these terms is nothing, because we don't have because greater than 5 would be 7, and all even and greater than 5 is 8 and 6, and since 7 isn't in that overlap, again, we can always make this case, but all these terms are 0. And so we end up with 10 plus 4 plus 4 minus 0, and you can write all those out if you like, but you don't have to, and you end up with the final answer of 18. Please let me know if you have any questions on exclusion or inclusion. If you're stuck on any homework problems, you can nominate them in the form attached. I'll talk to you later.